Okay, so this is the lead code number question number 1 by 3 part sum 2. So what is the given in the question? Here it is given in the binary tree there and the integer target sum there, and here we have to return all of the root to leaf path where the sum of all of the root node values in the path equal to target sum, and so each path should be written as a list of node values, not node references. Okay. So what is the given in the question? We have to return all of the path. What the definition of the that path? That path means all of the nodes consist in that path. Sum is equal, that all of the sum is equal to target sum. Means let's say we are say about this path. There's a 5, 8, 4 and 5. Okay. So what is the sum of all of these values? It become 22. So this is the our desired path. So we have to include this in our final answer vector there. Okay, so what's the idea behind it? First of all, so like we have to explore every the route to leaf path there. We have to like maintain a current path vector, and let's say at each node we have to value add its value to path, and we let's say we have to use extra variable here which we renamed as a current sum there. Okay, and when we reach at the leaf node, now we see if our remaining sum is equal to is equal to our target value, so we have to return it in our answer vector, and otherwise and if it is not, so we simply return and like similarly traverse all of the nodes here. Okay, one the most mandatory thing is here, after exploring a node we have to remove it from the path. Like it depends whether we use pass by reference or pass by value. Don't worry, I have to explain everything. I have to like you have to don't have to confuse about, or you don't have to bother about what's the our solution difference, or how our like these parameters changes over the code there. So we don't have to bother. We simply first of all let's say judging this using the dry run there. Okay, so first of all this is our the okay, from the initially we have to call for the DFS for the root node there. So when we we call for the DFS for the 5, so what is the sum here? So initially the sum here is 5, and there's a current vector, means it store only the 5 node there. Okay, now this sum is not over the desired value. What is the desired value over this? The desired value is equal to 22. Okay, so now it call for its left, so go to its left. Now here sum become 9, and here so we store it on our current vector, so what it become 5 comma 4 there. Okay, now it call for its left, so its sum become 20, and we simply push this in our current vector, so it become 5 comma 4 comma 11 there. Okay, now it call for its left child, so what's the status of its left child? There the sum become 27, and similarly push this in our current vector, so there's a 5 comma 4 comma 11 and comma 7 there. Okay, now since we reach at our leaf node, now we check the our sum is not our the targeted value, so we have to this is our not the valid path, so we return, or we have to check for the all of the remaining node. So so what it means, now we don't go for its left or right, we not need, since this is a leaf node, so we return here, and during returning, what are the first responsibility of ours? So we have to remove this part, this 7 there, and this sum also, the sum become 20, and the current path become 5 comma 4 comma 1. Now this is according to the code there. If we have to pass this sum or this current vector as passed by value, passed by reference, so what's the difference between them? Like let's say when I'm going to this code, so here I'm passing this into sum, this is passed by value, and this is passed by reference. So what the basic meaning between these? So like I'm returning here. Okay, I'm in each of the DFS code I'm passing in sum there, and there's a vector of int, there's a current vector. Okay, so what is the meaning of there here? Okay, so since if we have to go for the if we have to go for the some variable here, since this is a pass by value, pass by value is nothing but it simply copies value. So in case we return to its upper node, or it return its value, so it's some value, or it's automatically become 20. We don't have to manually set up this 27 minus 7 this value. But in the value, in the case of the reference value, this is not copy, this is the exactly operation here. So what it means, so in this case when we are to return, we should explicitly remove this current node here. Okay, if we don't do this operation, so after returning, our current vector become 5, 4, 11, 7. It 7 is already included in that part, and when it calls for 2 is pushed in that part, but 7 is already included, which is not valid. So let's summarize this part. Let's say we have to again recall this part during the flow of our code. So like simply what we see till there, so 11 it goes call from there, it's 11. So here it doesn't find any of the valid path. Now it call for the right part. Okay, so here what is it, some value here, the sum is become, there's a 22, and since we have to push this in our current vector, so 5, 4, 11, there's the 2 there. Okay, now since this is a leaf node, we should check whether it is a valid or not. We have to check at the ending of the path, okay, whether it is a valid or not. Now we see there is a sum is equal to target value, means this is a valid path. So what's our responsibility, or what's the main thing we do? We simply, when we reach at this condition, we simply push this vector. What I'm trying to say, we simply push this and this current vector there. Okay, now after pushing this answer means this is our main resultant vector of vector. Okay, so when it reaches to this condition, now it call for it return this value and simply answer this. Now here we again need to remove this 2 from its current vector. Okay, so we don't have to bother about sum, since this is passed by value, so this is a copy of the sum value. So here it becomes sum 25, 4. Okay, so it complete from its left right. Now it called this value to its, now it called this values to it. Okay, now it calls for its similarly right subtree. So let's dry run this part also again. So this is the sum, there's a 5 there, and then the sum become, it is 13. And what is the current vector here? So it becomes the 5, there's a comma, and there's a 13 there. Okay, so, okay, now it calls for this left part. So here sum is equal to there's a 26, and we have to push this in our current vector also. So this becomes the 5, 8, and there's the 13 there. Okay, now this is a leaf node. Now check whether it is targeted. No, it is not targeted. So in the case it not targeted, it we are to return, but before returning we pop back this element from our current vector here. Okay, so what it means, so it return its value to 8. Now it calls for its right part, so we have to use so here the sum becomes, since the 5, this 8, there's the 13. Now it becomes 17 there, and we simply push this in our current vector there. So there's a 5, there's a 8, there's a 4, there's a one mistake I'm doing here. Okay, this is 8. Okay, there's a 5, there's a 8 at the 4, sum 17. Now this calls for its left part, so it becomes sum is equal to there's a 22. Now current, it become this is a 5, 8, and the 4 and the 5. Okay, now this is a leaf node. Now check its sum is target value. Yes, this is value. So we again do simply same operation to this as there's the answer dot pushback of this current here also. And let's say so I do this same thing over here also. Let's say okay, like you know now, so there's no need to again, there's a need to write this again and again. Okay, so since this returning, we push this in our answer vector, now it returned to its value. And like before returning, it popped this value, so it goes to this. Now it goes to its last node. So what the sum here, sum become, there's the 18, and what's the current node there, there's the current node is becoming, there's a 5, there's a 8, there's a 4, and there's a 1. Okay, now this is, since this is a leaf node, check at this path. Since this is not a gated value, so we don't have to include this in our final vector, so it simply return. And during return, we know one thing, we have to pop this part. Now current become this. Now during returning, we pop this 4, so it become 5, 8. During this, we pop this 8, so current become 5. Okay, so we found what are the valid path there. So one of the valid path is this, and the another valid path is this. So there are the two valid path there. So now come to the code parting. So this is our main function. We first initialize our the main final answer vector there, vector, and for the each of the node there, we have to use our current vector there. Okay, and we initialize our sum variable here, so in sum equal to 0. And we since in the constraint there the 0 is inclusive, so we initially check for this part in sum equal to 0. If root is equal to 0, null, we have to simply return an empty vector here. Okay, now we have to call for the root, that the sum, there's the current, and there's the ans, and there's the target sum. Okay, and after returning, we simply return this our final vector. Okay, this also we also can do this part. There's like we have to define this as globally current vector or sum, but I have to don't go for this side. There's a many of the option for the writing the code. So now there's a definition of this function dfs. There's the node, there's the sum, there's the current, but this is passed by reference. We can also pass this by value. So if in case we have to pass this by value, we don't have to bother about removing this part. But since here it is passed by reference, so during returning we have to remove this part. But since this is by pass by value, so we don't have to bother about the subtracting that element from its sum. Okay, and there's an answer vector there, and there's a target sum. Now at since in each of the function we simply add the base case, and there's a node is equal to null, we simply return. Okay, now what first we do, the updation of the its sum is equal to node value. Now we add each this value to our current vector. Okay, now we check for the leaf node. Okay, this let's say let's come to this part, and like doing for, we have to call for its left part, and we have to call for its right part. And there's the one crucial thing is, since we are using this backtracking, so this is the more crucial step. We have to when we have to return, we have to go to upper part, so we have to remove our this element. So current dot pop back. Okay, now let's discuss for this. When we reach at left node, we check whether there's a both cases possible. If this is a valid or this is not valid. So how is it valid? So sum is become target sum, and how is not valid? Sum is not equal target sum. So in case it become valid, so we push this in our main final vector, which is ans dot pushback current. And now returning current dot pop, we have to remove this part explicitly and returning this part. Similarly, if it's not able to find this path as valid, so here also we have to pop this part and return this. So this is the code there. And now for the we have to go for the time complexity. So since every node visited once during the path, so what's the time complexity here? Let's say since every node is visited once only, so that's why there's a time complexity become the and we there's a one thing also, since we have to copy the path, our this current path in our answer, so this also cost of, so its complexity becomes of n of into h. Why? Because this is for the, since each node is visiting only one time, and since we have to current path in our answer vector, so that take of h part, this is approximately of h. And similarly for the like there's a space complexity, this is there's a of this is, okay, so there's a space complexities of h. So this is the question, and there's a no need to like there's a another method of doing this code, since we have to pass two extra variables here, there's a current sum there and there's a target sum. So in many of the questions you see we also can do this by passing only one variable, that is our remaining sum. So we pass our remaining sum as our target sum there, and simply when it reaches to zero, when it reaches to zero means we achieve our targeted sum, so it return our, so this is goes to this case. So by this like you can skip that these two variables, you can do this by only using one variable also. So that's the discussion.